All right, we're diving into a process that's at the white-hot core of, well, pretty much everything around us. We're talking about how you turn molten steel into the actual building blocks of our world. Let's get into it. So just picture it for a second. A glowing river of liquid metal, hotter than lava. The big question is right there. How in the world do you take that liquid fire and give it a solid, usable shape? That's the whole challenge of steel casting. So, what are we really talking about here? Well, steel casting is that key industrial step. It's where the liquid stuff solidifies into these semi-finished forms. You can think of them as basic building blocks, these billets, blooms, and slabs, that eventually become just about everything made of steel.
But hold on, before a single drop gets poured, there's this really important waiting game. The molten steel just sits in a giant container, it's called a ladle, for about 5 to 10 minutes. And this little pause is absolutely crucial because it lets the heavier gunk, the impurities, sink to the bottom. It's called decantation. It's one of the first and most important steps to make sure the final steel is clean and strong.
Okay, so what was the first answer to that big question? For a long time, it was all about ingot casting. It's a method that's super straightforward, really powerful, and it was the foundation of the entire industry.
The whole idea behind ingot casting is actually pretty simple. You take these massive cast iron molds, and you just pour the liquid steel right inside. The shape of the mold itself is already designed to be a rough version of the final product, so a square mold for long stuff, a flatter one for steel plates.
But even with this simple method, you've got a big choice to make. You can pour it right in from the top, that's quick and dirty, gets the job done fast. Or you can use a more complicated setup where the steel fills up multiple molds from the bottom. Yeah, it's more expensive, but because the steel fills the mold so gently, you get a much higher quality product. And for something like a high-pressure pipeline, where any weakness could be a disaster, well, that quality is everything. It's that classic trade-off, speed versus quality.
But of course, the industry didn't just stop there. The next big jump forward was a total revolution. It was a method that turned steelmaking from this batch-by-batch job into a non-stop flowing river of solid steel. And this is continuous casting.
So this all happens inside one incredible piece of machinery. Let's walk through it. First, the steel flows into the tune dish. Think of it like a buffer tank that feeds the whole system. From there, it hits the crystallizer. This is a water-cooled copper mold that instantly freezes a solid outer shell. As it comes out, it gets blasted with a powerful water spray that solidifies the gooey core. All this time, drive rollers are pulling this new strand of steel down until finally, a cutting torch slices it to the right length. And the whole thing never stops. Now you might be thinking, okay, cool, you've got this amazing machine, problem solved, right? Well, not quite. There's another huge detail that really affects the final steel, the actual shape of the machine itself.
And that's a fair question, right? I mean, the steel is getting solid, and it's being pulled through. Does it really make that big of a difference if the path it takes is straight or curved?
Oh, you bet it does. It matters. A lot. And it all circles back to those impurities we talked about earlier, the inclusions. It's all about giving them a clean way to get out of the steel as it solidifies. And this table just lays it all out perfectly. In a curved machine, as the steel makes that bend, the lighter impurities float up and can get stuck near the top surface. Now that's totally fine for your average general-purpose steel, but in a machine that's completely vertical, those impurities have a straight shot up and out of the liquid's center before everything locks into place. That's exactly why vertical machines are the go-to for making the absolute best, highest quality steels, the kind you need for high-performance car parts or aerospace components. So, it's pretty clear continuous casting was a complete game changer. But what were the real, tangible advantages that made it the undisputed champ of the modern steel world? The perks are just massive. For one, it cranked up the speed up production like you wouldn't believe. It got rid of a huge source of waste from ingots called shrinkage cavities. Those are basically just empty pockets that form when the metal cools down. Plus, it completely skips the first super energy-hungry step of rolling the steel into a basic shape, because it makes those shapes right from the get-go. All of that means you get way more usable steel from every ton you melt. It's just incredibly efficient. Really, if you want to boil it all down, this is it. You've got fewer steps, which makes the whole process simpler. You've got way less waste, which makes it cleaner, and you get a higher quality, stronger, and more reliable product at the end. And this is the part that matters to all of us. This incredible efficiency isn't just some boring industrial detail. It's a huge reason why steel, the very backbone of our cars, our buildings, our whole infrastructure, is so strong, so reliable, and so affordable. This process literally underpins the world we live in.
You know, that jump from ingot to continuous casting completely revolutionized how we build our world. It really makes you think, what's going to be the next material or the next process that completely changes the way we create things all over again?